Megan? Homework for number 3. Sure. This was the trickiest one on this homework 4, which is not surprising that you guys have asked questions about it. And the tricky thing about this is that the form that I've written this in is not at denominator. It's not form 2 because we have something added or subtracted at the end. Everybody agree with that? So you have two options. You could write this in form 2 by making a common denominator, basically multiplying the top and bottom, or multiplying 2 over 1 on the top and bottom by 3x minus 3, and then like adding the fractions, and you'll get it into that form 2 situation that you can deal with. Or you could get into the form 1 by factoring a greatest common factor from the denominator. And then if we divide the numerator and denominator by 3, we can get it into form 1. So either one of those two approaches would be fine. Since I've written it in form 1 there, we can see that the h is -1, so the vertical asymptote is just x equals 1, right? But what I wanted to point out to you guys is that really, regardless of the form, 1, 2, or this form, the vertical asymptote is just where the denominator is equal to 0. Right? If I take 3x plus 3, set it equal to 0, and solve, I get the -1 that I would get here, right? And if I had written this in form 2, the -d divided by c is exactly what I'd get if I subtracted 3 from both sides and then divided by 3, right? So just as an aside, I'll fill in the rest of this. Megs, are you so far so good? HA is y's. Vertical is the x's. So x equals means that the x coordinate is constant the whole time, so you're getting a vertical line. No, it should go this way. Hal's.
What is ARX?
It's just me abbreviating all real numbers.
Oh, okay.
And then list the thing that it can't equal. It's like everything except for this number.
Okay.
Is basically what we're saying there. Okay. Meg, you good still? No? You have some follow-ups? Go ahead. Okay. And that's okay, right? That's the point of doing the homework and asking questions, is that sometimes we make mistakes and we got to get some stuff straightened out, and that's okay. That's no big deal. So vertical asymptote is the middle. Then I'll do 2 numbers less, and then 2 numbers bigger than. And then let's see here. Let's see, that's going to be -12 plus 3 is -9, so that's -2 and 2/9. And that's going to be 2 over -6. That's -2 and 1/3. And that's going to be 2 over 3. So that's going to be -1 and 1/3. And 0 is oh, hold on a second. What did I do here? That's going to be, sorry.
Mr. Claude,
What's up?
would it be incorrect if we didn't have the repeating signs?
No, I mean, just graphing. So if you rounded these things to like 1 decimal place, that's fine. I'm just trying to be precise so that people aren't like, oh, that's not exactly what I got, you know, if they're looking at answers or whatever. But you're graphing, like nobody's going to be graphing so accurately you can do better than 1 decimal point. You know what I mean? So that's that. And then 2/6. And then 7/9. Megan, are you okay with what I'm doing there? Okay. So drawing our asymptotes. So -2 for my horizontal. And then -1 for my vertical. And we'll plot our points. So -4 and -2 point. Oops, I'm dumb. What did I do there? Put my horizontal asymptote in the wrong. -4 and -2.2. -3 and -2.3. And -2 and -2.6. So it'll look something like that. Then I have 0 and -1.3, 1 and -1.6, and then 2 and -1.7. So it'll look something like that. Meg, oh, you good with that? Okay. Joe, I saw your hand up earlier. Is it this same
It
question?
was the same question, but it's from homework 3. I have another one. We can go over it.
Sure, happy to do that.
Can we go over number 9 from homework 3, please?
Sure,
Thank you.
no problem. What is beeping at me? All right. Looking at homework 3, number 9 next. So the first thing I'd want to do is try to factor anything that I can, but if I look at number 9, there's really nothing to factor there, so we're good to go. So I'm going to note that this is not a proportion, so to solve this, I'm going to be clearing fractions. To identify the least common denominator for all fractions, it's just going to be x minus 3 times x minus 5. Good with that, Joe? Okay. So I'll multiply both sides of my equation by that least common denominator and distribute things through. So I'll write this all out. Oops. And then we'll reduce, so and that was supposed to be minus 5, and chew. Okay, still doing good. So we're going to have 3 plus x times x minus 3, 3 times x plus 5. Okay, I'm going to multiply all this stuff out now. So I have x squared minus 2x minus 15 equals x squared minus 3x equals. So this is now something I'm going to combine like terms and move everything onto one side. So I have 1x squared, 2x squared, and when I subtract that one over, it goes back to 1x squared. I have negative 2x, negative 3x is negative 5x, and when I subtract another over, I have negative 7. And I have negative 15 and then negative 15, so when I add that over, I get 0. You good with that, Joe? To solve this, I'm going to just solve it by factoring because there's just a greatest common factor. To solve this, I get x equals 0 and x equals 7. And now I need to check. When I go back and I look at my into x minus 3, I get negative 3. That's not 0. If I plug it into x minus 5, I get negative 5. That's not 0. So 0 is good. If I plug 7 into x minus 3, I get 4. If I plug 7 into x minus 5, I get 2. So that one's good. So those are 2 solutions.
Yeah, I don't have a problem like following it. I get confused on the multiplication sometimes. I think that's my one problem.
Yeah, if you need to write more stuff out and go slow, just write some more stuff out and go slow. Like I buzz through some of it sometimes, and like if you're just not, if you do better by like, okay, I'm going to really foil this out and write everything down and like.
That's probably what I should start doing because sometimes I miss numbers and I get the wrong answer.
Yeah, so the shortcut that I'm using is just multiply those, and then you don't have to do the foiling.
Oh, and you can do that every time?
As long as the leading code,
Right.
you can do that.
Okay, sounds good. Thank you.
You're welcome. Benji.
Can we do number 10?
Sure. So I'm gonna just like used up all that space up above. Cool with that, Ben? All right. So again, I would start this the same way I did before, to finding a least common denominator. Hopefully it's not hard to see that least common denominator is gonna. You agree with that, Ben?
When you got x, yeah.
Okay. So I'll multiply that to both sides over x minus this. X times x minus 3 times 3 Feel so far so good?
Yeah.
Okay, so let's reduce. So that leaves me with.
Good. Got that.
Okay, I'm going to combine. I'm left with a quadratic equation. So to solve this, I'm going to move everything onto one side. So I'm going to subtract negative 4x. And then I'm going to add 3 to both sides to get a quadratic equation equal to 0. I notice that that's a quadratic that I can factor because the two things that multiply to give me negative 3, or I'm sorry, positive 3, and then add to give me negative 4 are negative 3 and negative 1.
Yeah. So. Oh, I see what you did. All right, I got that.
Or you could use the quadratic formula there if you prefer. That's fine also. So to solve this, I set each of them equal to 0, and I get 3 and 1.
All right.
Now I need to check. So if I go back to the original equation and I plug 3 in, that'll give me a 0 denominator here or here, right? So I'm going to discard 3. That's not a solution because it gives me a 0 denominator somewhere. But if I do the same thing for 1, that's fine, right? 1 minus 3 is -2, and 1 is just 1, so I have just one answer.
Because I got confused. I didn't know if you could just get one answer or not. Okay, so that's what I got.
Yeah, so you could get one answer, you could get 2 answers, you can get 3 or 4 or 5 or 10.
It doesn't really matter how many you get.
It doesn't really matter how. In fact, you can get no solution. You can get no answers.
All right.
I think, in fact, on one of these on here, Joe?
So if it's not a proportion, I think, when you're like, whatever, you know what I'm talking about?
The proportion is where you can cross multiply.
That's what it's called. So if you're not cross multiplying, we have to find the least common denominator in order to.
Yeah, and clear fractions even with a proportion.
Okay.
You could still use that technique on. What you can't do is cross multiply if you don't have a
If you don't have a
proportion.
proportion.
That one is specific to proportions. The clearing fractions, though, works regardless. Yeah.
And then to clear fractions, obviously, you have to use the LCD.
Yes.
And then from there, we go to multiplication and we figure out our answer.
Yes.
Sounds good.
Can we do one more?
Sure. Which one do you want to learn?
Preferably number 4.
Okay.
Yeah.
Okay. All right. So again, first thing I would do is to try to factor this, but clearly there's no factoring to happen. So let's go ahead and find our least common denominator. It should be easy to see that that's just x because we have only one denominator, and that denominator is x. So when I multiply it to 4 over x, I'm left with just 4. When I multiply it to x, oops. So far, so good, Ben? Okay. It's quad sides.
It goes to
Yeah. So like I'm doing this.
yeah.
Meg?
So it's okay to like rearrange the order so that like it works.
Yeah, because like addition is commutative. So like, right?
Yeah.
So doesn't itself is commutative, whether you're talking about variables or numbers. As long as you're keeping the negative signs in front of the numbers, you can move around the order. Yep. So the two things that multiply to give us -1. You good with that, Ben?
Yeah.
Okay. So my answers are 4 and 1. If I go back and plug 4 into x, I get 4, not 0, so that answer is good. If I plug 1 in for x, I get 1, not 0, so that answer is good. So they both work.
They both work.
Yep.
All right, thank you.
No problem.
This question may not really make sense, but like you know how in the beginning you did LCD X or whatever? On the test, if we didn't like write all that out, would it be incorrect?
As long as I can see what you made, like what your LCD was.
Like,
So, like-
yeah, as long as we make it clear, but like
So like on
Oh,
this,
yeah.
like on this step where I've gone ahead and I wrote it 3 times, and it's really easy for me to tell like what you
Yeah.
used for your LCD. If you didn't label what your LCD was, like I would know.
yeah, I got
So like that would be fine. Like
Well-
that amount of work is fine, even if you didn't write that down specifically.
yeah, but like for some of the harder problems, I see what you're saying. That would be harder stuff.
Yeah.
Yeah,
So like if you went straight to this step, that would be no bueno for me
yeah.
without telling me what your LCD was.
Uh-huh.
You know, like that I would insist upon. Does that make sense, Ben?
Yeah.
Okay. Meg?
So for number 4, did the 2 x's cancel out and then there multiplied the least common denominator by
Right. So like that's what you're asking? Okay. Yes. I said it aloud because it was such a kind of the multiplication was trivial there. There's only one thing that was going to do any canceling, so I just kind of did it aloud. Is that cool?
Yeah.
Okay. Alexis, you said you wanted to,
yeah.
or I'm sorry,
On number 4,
Alex.
can we do number-
There's no
can we do number
is.
5?
On which,
Number 4.
sure. I don't know if your question got handled or not, but I figured I'd come something about it earlier. Okay. So I think this one just kind of goes off the screen a little bit if you got some weird numbers and you're like, I wasn't. This one does, like when I did it, I picked one set of numbers and the graph was fine, but when I did it again for someone else, I picked a different set of numbers and I had some stuff that was off the scale, so that might have happened. But let's start here. So the horizontal or the vertical asymptote I find by taking negative d over c, and here's my c, negative of negative. What is going on? Negative of negative 3 over 4, or just 0.75. Y is a over c. So it's in my range. So I'll put my vertical asymptote in the middle of my table and then pick some 3 numbers bigger and smaller than it. And I think the 1 was the one that I get a funky number on. So if I plug negative 2 in, I get 1 over negative 7. Nope. Yeah. No. I get 1 over negative 11, which is basically about negative 0.1. I think it's 0.09 repeating or something, but like whatever, rounding it to 1 decimal point. If I plug negative 1 in, I get 3 over negative 7, which I think is like 0.4257. It's like a 6-digit repeater, but I'm just going to round it to like 0.4. And if I plug 0 in, I get 5 over negative 3, which is negative 1.6. If I plug 1 in, I get 7 over 1. 2, I get 9 over 5. So that's 1.8. And if I plug 3 in, I get 11 over 9, which is like 1.2 repeating. Is that okay, Alexis?
Yeah.
I'm sorry, I keep doing that. You're not Alexis.
I think I did like the ancient, the asymptote.
Oh, yeah, if you goof those up, everything is all funky looking.
Yeah, I think that's what it
Gotcha. Okay, so 0.75 is maybe... And 0.5 is like there. And I have negative 2 and negative 0.1, negative 1 and negative 0.4, and then 0 and negative 1.6.
Is there food? May I go use the restroom real quick?
You may.
Thank you.
No problem. Okay, come on. Okay. All on questions for you guys?
just where like number 4 on number 4. I was just wondering if you could just show how to get the HA and VA.
So the VA or C. So my C is here, which is 1. So I have negative 3 over 1, or just negative 3. Okay with that? My HA is A is 1, and the C is 1. So that's just 1.
Thank you.
Megan?
Maybe finish off.
Sure. So those will be the x's and y's or the x's that I pick. So if I plug -6 in, that gives me -4 over -3, so that's like 1.3. If I plug -5 in, that gives me -3 over -2. If I plug -4 in, that gives me -2 over -1, so 2. If I plug -2 in, that gives me 0 over 1. If I plug -1 in, it gives me 1 over 2. If I plug 0 in, that gives me 2 over 3. Totes. So I have -6.5 and 0. What's that? Okay.